the first equation that we created was y equals 2 times the quantity of x plus 3 squared. The next thing that needs to be understood is what the parent function is. The parent function is y equals x squared, and looks something similar to this. The next thing is, for the equation, we must start at the origin. Then we must shift to the left 3 because it is plus 3 and it switches sides. The next thing that must be done is having a vertical stretch of 2. Since there is no reflection or there is no shifting up or down, this is where the parabola will stop. Since it is a vertical stretch of 2, we know that the next point will be up 2 and over 1 on both sides. With this, we can connect the points and make a rough estimate of where the next points will be.
The equation that we are going to be working with is y is equal to 1/2 x squared minus 2. Now, as indicated by the x squared, it shows that our parent function will be the quadratic, which, as seen here, is a slope on either side of the origin that originates there. And this equation would be known as y is equal to x squared. From here, we can return to our original equation of 1/2 x squared minus 2. And because there is nothing being added or subtracted to the x, it means that there will be no shift either right or left. We move on to quantities. So the numbers that I'm going to be using are 2 and 4. This will give us 2 basic points that we can use to start our graph. So because x is equal to 2 here, we would substitute x for 2, and because of the order of operations, we would start with x squared being equal to 4, and that times 1/2 is equal to 2, which would make the first point 2, 2. If we continue on and we substitute x now for 4, then 4 squared is equal to 16, times 1/2 is 8. So our next point on this graph will be 4, 8. Knowing this, we can start to make our first parabola. So we are going to plot the points 2, 2, which is right here, and 4. And because our axis of symmetry is 0, then we can just use these points and create the opposite by reflecting over the y-axis. However, our parabola isn't done because we have not used this part of the equation. So I'm going to move down to another graph. So the equation is y is equal to 1/2 x squared minus 2. Because this minus 2 is not inside of the function, but outside of it, it becomes a shift down 2. So this would be our new starting point. And then you would shift all of our previous coordinates of 2, 2, and 4, 8. We would shift the y part of each coordinate down 2. So these new points would be 2, 0, and 4, 6. And reflect them again over the y-axis.
This equation is going to be the most complicated out of all the sets of parabolas. This equation is -4 times the quantity of x minus 1 squared plus 3. Again, the parent function is y equals x squared. Again, we must start at the origin, and this time we're going to move to the right 1 because it is a -1 and it switches signs. Then we must have a vertical stretch of 4. The next thing that must be done is, since it is a -4, it must be reflected over the x-axis. It will shift up 3 units because it is +3 on the outside of the parentheses, meaning that it will add 3 to all of the y coordinates. The resulting parabola is the one highlighted in yellow.
The next equation that we will be working with is y is equal to negative the quantity of x plus 4. The first thing is that we have to look at what is directly affecting the x value. And the only thing that is affecting it is this negative. This indicates that there will be a reflection over the x-axis. And from the original parent function of the absolute value being y is equal to absolute value of x, which looks like this, we would reflect it over the x-axis, which would be however, since there is a +4 outside of what is directly affecting the x, we then have to have a shift up 3. I mean 4. Sorry. We would shift up 4. This would cause some of the points that we have, which are the 1 and -1, and then 2, -2. These are 2 of our points. And so the y components of these points would add 4 to each of them. Our new 2 points that we're working with are 1 and 3, and 2, 2. And because our original starting point was at the origin, it would become 0, 4. This would cause our parabola to move up for 1, 2, 3, 4. This is our starting point. 1, 1, 2, 3. And 1, 2, 1, 2. And here we have the graph of the equation y is equal to negative absolute value x plus 4.
Difficult to understand than the parabola, since it essentially has two parabolas on it, one going up and one going down, aka one happy and one sad parabola. The equation is y equals the quantity of x minus 3 cubed plus 1. The parent function of this is y equals x cubed. The first thing that must be done with this specific equation is shifting right 3. Because it is minus 3, it shifts to the right because it changes signs. The next thing that will be done is it will shift up 1 because it says the equation is plus 1 on the outside of the parentheses. This changes the vertex to 3, 1, which means that since it was plus 1, it changed the y coordinates up by 1. The final and resulting cubic function is the one highlighted in green.
The last equation we will be working with is y is equal to negative 2 times the square root of x plus 3 plus 2, and that's on the outside of the equation, of the x value. So the first thing that we need to look at is what is directly affecting the x value. I'm going to start with this plus 3. This indicates that the entire graph will shift 3 to the left because it is the opposite. This is a square root equation, which will end up being that the parent function is this graph, which is y is equal to the square root of x. From here, we can go back to our equation and take this and shift the entire graph 3 to the left. 1, 2, 3. Which will end up looking something like. The next thing that we will need to do is take into account this part of the equation, which indicates that there is a vertical stretch and a reflection over the x-axis. So if we move down to a new graph, I'm going to. And so we can make a table of x and y values that show the points that reference point. And then we have, because it was shifted to the left, 1, 2, 3. Now it's 1 and negative 4. 1, 2, 3, 4. And last but not least, we have to take into account this, which causes the y component of every point in this graph to shift up 2. So if we move to a different graph, the equation, which is y is equal to negative 2 times the square root of x plus 3, and then plus 2, our reference point was 1 and negative 4. And our starting point of our function was negative 3, 0. Because this part is outside of what directly affects the x, it causes all of the y components to shift up 2. This would cause our two reference points to become 1 and negative 2, and negative 3, 2. And that's how you graph the equation y is equal to negative 2 times the square root of x plus 3 plus 2.